Hello. I was just typing into the Discord server. Hey, that's the Discord server right there. You should come to this hangout if you're in Discord. And that's what I was trying to tell people. So 1 second. Let's just put that in there. Go to Bret.live. Right now, people. Right now. We're doing this live thing right now. That's why we had this 4-minute intro, is to wait for the internet to do its thing and you all to join. Hey, everyone. Thanks for being here. Martin's here. Yvonne's here. We're gonna bring the crew on in a minute. Luigi is just became a member. I throw out the reggae horn during the intro, and I really appreciate you new members. All right, let's talk about some things. So, if you haven't been here before, welcome. Normally I got Nermal with me. He's not here. He's traveling. He's actually in DC at a conference or something. He's just such a big wig at AWS. He's always at a conference talking about things. Did you know that we turned this into a podcast? So you can watch it here on YouTube. You can jump into any podcast player. It's called DevOps and Docker Talk. But it's also now, because one podcast isn't enough, and because we have to talk about AI constantly every day, we started a new one. So I want you to check this one out. It's also in all the podcast players. It is exactly the same thing. It's just a theme. It's just a focus of DevOps that is using AI. So this isn't about using DevOps techniques to run LLMs. That's a different show. Although we'll probably mention that and talk about it on this show. This show is about finally getting AIs to get good enough with the agent modes and all these MCP things that we all keep hearing about, being able to use that stuff to actually do the work of platform engineering, DevOps, and all that. So that's what that show is about. And the reason I started the show is because I need to figure it out. So I'm going to have smart people on who know how to do this and are trying the bleeding edge tech. And we're going to be making a bunch of episodes this year. I'm super excited about it. So jump on that free podcast. I'm also working on a new course, also related to AI and DevOps, that you will be hearing about soon. So come back to the show or get on the newsletter. So you can get the newsletter at bret.news. Just to prove that it exists, there it is. And an increasing number of these episodes are about AI tools and how we can use them for DevOps. So jump on that, Bret.news. All right, let's get to it. Bringing on my guests. All right, so we've had both of these gentlemen. Hello, everyone.
Hey there.
Hi.
We've had both of you on before. This is Yvonne and Vedran. Both, I think you're both co-founders, right, of Daytona?
Yeah.
Yeah. And we've had you on separately. So Yvonne was on a couple years ago when you first launched Daytona, and we dug into that, and we're not going to talk about that because we're talking about something different now.
A lot has changed.
Well, and like, to be fair, I mean, what startup of the last 4 years hasn't completely like changed, right? And then Vedran was at KubeCon in Paris. And I think it was Paris, right? Yeah. And we did a quick interview right in the middle of the live stream. You jumped on, and that was great. And we're here today to talk about agents and infrastructure for agents. And we were going back and forth before the show. I have some learning to do here because the problem space is not something that I am in, because I'm not yet writing agents, even though it sounds like something I definitely want to do this year. So what exactly was the problem you were seeing? It sounds like you were seeing a problem when you were working on other stuff for Daytona, and you discovered this problem?
Yeah, actually, so originally what Daytona did or was a, let's call it, automation tool. So we helped automate and streamline dev environments for human engineers. And I have to say the word human because now there's non-human engineers, right?
Right.
And so you can think of it as these very large companies or enterprises have, thousands of engineers. And as we all know, setting up your dev environment, which can be just a Docker, it could be Kubernetes, it could be whatever, something can be local, something can be remote, something can be hybrid. It could be monorepo, it could be polyrepo. There's like so many things that can be there, and it takes a lot of time and not simple. And in the meantime, something called agents came about, and we've heard of coding agents, and that's not what we do. But agents, if you can think about them as humans, then they have to do the same thing to set up, let's call it a dev environment at this point, as humans do. And so instead of helping humans, we decided to help agents. And I don't know if that makes sense, but that's sort of what brought us here.
The humans aren't as interesting as the robots right now, anyway. So this is the more interesting path. Um, that makes sense to me conceptually. Are How is this related to MCP tools? Like I mean, the internet is flooded with everyone discussing MCP, and we talk about agents as this nebulous thing. Like I think all of us now in our IDEs, we see the agent mode option, and it gets a little bit more autonomous with the things it's doing in the background. We don't know what it's doing in the background, right? We don't. I don't actually think about the fact that it's running stuff on my machine or where it's like. Is it doing that work in a container? Is it doing that work right on my file system? Obviously, it's editing the files, but because it's changing them, but I don't know how it's editing it. And it's a little. There's like this facade in front of what's really going on in the background. Is this somehow related to that or to MCP in any way?
I can talk about that a bit. And so I'll try to take a step back and explain what the things that we do. And so let's start with let's just like Cursor, which you mentioned, right? And Cursor can edit your files, and it does that. But Cursor, for the most part, it actually can't run any of your files on its own. So it can't go off and try things on its own without you accepting what it
Mm-hmm.
suggested. And the reason is because it can break your machine or can break the code or
Right.
can do whatever, right? It's still like sort of a human in the loop. It's like, oh, I think this. Do you want it? Yes, no, or whatnot, right?
It's
Um,
previously tried to erase a systems directory where Xcode was installed because it couldn't. This was like 4 months ago. It couldn't build because there was a problem in the code that it wrote. So it got so frustrated that it was trying to do an RMRF on a
yeah,
system directory right before I said no.
and so you don't want that to happen, right? And so
Right.
though we talk about those agents like a cursor sort of as assistants, even though there's like an agent mode, but they are assistant, like they're working with you specifically.
Mm-hmm.
And then you have autonomous agents, which are more like raw, they have long running tasks. And so if anyone has heard of like Devon.ai, and I'm mentioning this one specifically because they were like the leader and everyone was talking about this startup. Basically, it's like here is a task there. You don't look at the ID, you don't anything. It just goes out and does it, right? It'll start coding on its own. It has its own ID, it has its own terminal, it does all these things. And so where does it do these things? Where is
Right.
that dev environment? Like an agent basically is a piece of software that connects to an LLM and to a human or like someone that will use it. But where does it run that code? It has to run it somewhere. It can't run it in its head, right? And a simple example of this is if you take Claude or ChatGPT and you say, write me this piece of code, it will obviously do that. I'm sure everyone has done this before. But tell then ChatGPT or whatever to show you the output of the code to run it.
Mm-hmm.
And it won't do this. It can't run the code because you have to set up a dev environment to run the code.
Right.
Note, I
Right.
know that OpenAI now launched Codex, but Codex is essentially that. It is something equivalent to a Daytona with the ChatGPT on top of that, right?
Okay. So not all agents like to me eventually it feels like every SaaS is going to have agents. Like it's just every online
Every
thing I
SaaS is
use
going to be an agent. Every SaaS is going to be an agent.
is going to be an agent. Yeah, or have agent. Yeah, going to be an agent. Okay, so not all of those. I mean, let's assume that they're actually doing good practices and like they're running this code from a container. How is if Devon is executing something in a container, how is this different than that? Like because like me and my audience, I presume they all run containers. They're well versed in orchestration and like Docker. Um, why isn't this just like all running inside a container?
So it can be, but the limitations are there's quite large differences between what an agent needs and what a human needs.
Hmm.
And I'll start off from like the least to the most, what I believe are important. And so the number one thing is obviously humans enjoy things that are faster and don't want them to take a long time. But if your agent is running in interactive mode in the sense of like a human is talking to it and looking back to it, you don't want to waste a lot of time. So these environments then have to spin up instantly fast. And so for us, they spin up in like under 30 milliseconds plus latency of that network. So that's like really, really, really fast, right? The time it takes you to blink, that's how long it takes to spin up. Another thing that we have coming is unlike a human, which you can work on one environment or one container at once, one dev environment at once, an agent can try multiples. So it's basically it can enable the agent to fork a machine. So it can take the state of the machine, it can fork it 5 times, 10 times, 100 times, whatever, and then try multiple outcomes at the same time, and then see which ones are good and bad, or which ones work and which ones don't, and then take the ones that are good and then essentially can fork it again if it wants. So for the people that have watched any of the Marvel movies, you can think about it as the multiverse. Like basically, if there's a choice, the agent can branch from that moment on and have an individual runtime for it. And so that's not something that humans really can grasp. Like I can't do that.
Right.
I don't know if you can, Brett, but like that's not something that I can do run in parallel, right?
Yeah. Yeah, and we're also like there's this everyone says this casually, like we're all just going to have a bunch of AI agents just building our things in parallel, and this one over here is working on some infrastructure design. This one over here is building me a tool, and they're just going to, and I go away and I sip coffee and I come back. And I'm already there, but I still have to use like multiple cursor windows or multiple, ChatGPT windows or something like that. There's not like we don't have the next level yet where the same tool I feel. Oh, actually, there is a background thing in Cursor now. I just heard about this week. I don't know if that's related, but I guess that's full agent mode or something in Cursor.
Yeah,
I don't,
and
I don't know
so
if either one of you.
it could like so regarding cursor, it essentially to your point is there's a story that we have a lot of agents running around and doing things, but they still can't do that because they're locked into, for the most part, they're locked into the environment that they are. So again, if
Right.
you take Cursor or ChatGPT or Claude or these like agents that people know, they're usually locked into the context of what you type into or share into that window into which they exist. And that's where like MCP comes into play
Right.
to an extent, as you mentioned. So what MCP, it enables an agent basically almost on the fly to connect to any service out there, right? There is an MCP server to your question earlier in Daytona, which they can use that, but I still believe that for Daytona at least, which is a quite complex tool, and Vedran can share a little bit more about what we've built inside that in a second, is that because it's a complex tool, it is harder for the agent to grasp. It takes a lot of context for it to understand. So it's still better to natively integrate it yourself. That being the human developer that is building the AI developer that is then integrating with that, if that makes sense. So there's a lot of
Yeah.
hierarchy in there. Um,
So,
Go
oh,
ahead.
sorry. I was gonna give you a hypothetical.
Sure.
Um, I have a little side project. Haven't put it out there. It's just gonna be a free little thing where taking a bunch of different repos and projects that I like, and I'm tired of reading all the email updates of the. Basically, I'm scratching my own itch, solving my own problems. I'm trying to keep up with CNCF projects. There's over 30 graduated now. I can't even keep up with all those. So I subscribe to all the release notes, and I get tired of reading all those. So I would really just prefer to have a summary, the important bits, the major features, smash all that into one email or one something, and decide, well, maybe I'll use an LLM to make a podcast, and there's different ones that turn text and audio and all that. And so this could, I'm not really designing it as an agent, but I suppose if I provided a website in front of it and then allowed it to go off and do things on behalf of users, it might be more agentic in that way. So in that, I was just planning to call out to LLMs and then do things in the container that it's running from. But now that I'm thinking about it, the reality is it's probably going to need worker jobs or something like that, a traditional sort of microservice architecture. It's probably going to need something else to spin off and do the work for each individual podcast to go and summarize and talk to an LLM to turn it into an MP3 file. And like these are all API calls. Is that in that model? I'm trying to think about how this would function in that model. In that model, like if I needed to do FFmpeg or something like that on an MP3 file. So that's like a tool call. And in the
Yeah.
past, like 2 months ago, when MCP was coming out, or I was learning about MCP 3 months ago, 4 months ago, something like that, I would have just assumed that I would try to do something with MCP to a tool call inside of a container. Docker's now got this thing on Docker Hub where you can find different MCP tools in a particular format that they like, but they're really just containers underneath. So if I decided like I wanted to do isolated work, and let's say that this is really just an MP3 revision, I need to run a particular CLI tool. Is that
Yep.
something where I would potentially spin up some? I would use your SDK to spin up that tool inside my app, and that would be, and you're comparing this a little bit we were talking about MCP, and in this case, I don't really need MCP because I have access to the tool. And
Yep.
and for the audio listeners, they're
Exactly.
shaking their heads like I'm not crazy.
Yeah, no, it's exactly that. So
Yeah.
what we like to explain is people don't a lot of people take agents as basically ChatGPT cursors, like agent mode or whatever it is, not thinking about like how far this can go into the future. And so we start with running code essentially. But if you think about your workday, whatever you do today, if I took away your laptop, there's very few things you can do, not just coding, basically downloading files, encoding files, like doing whatever. And an agent also can't do those things without a computer. So in that variation, and of course you want it to be isolated because if it messes something up, you don't want it to mess up anything else that it's doing. And so you can
Right.
spin up isolated machines of it. You can think about it having like an isolated MacBook for every single thing that you're trying to do or the agent is trying to do. And so the agent cannot do that without that machine to be able to run, right? And
Right.
because the agent is non-deterministic and can hallucinate, can do different things, you want to make sure that each of them are isolated on your own. And that's why Daytona and products like it are made specifically for agents with APIs for everything, which you can integrate, but also they can spin up really fast. They can be stateful, but they can also be ephemeral. Like you can kill it. You know, if something screws up, it's like you just kill it and spin up another one, or the agent will kill it and spin up another one, right? So yeah.
Yeah. Do you have like an example, like not necessarily an anecdote, but like a customer or something where you can talk more specifically about the
What they
point
use it
at
for?
which, what's that?
What they use it for? What they use the product
Yeah,
for?
like I'm thinking, I'm trying to think about because this feels like an infrastructure problem, right? Like we're our architecture problem, right? We're talking about
Yeah.
people building agents, which is a fairly new paradigm. A lot of developers maybe aren't doing that yet. They might have apps that call out to an LLM to get a response,
Yep.
but
And that's
they're
the
maybe
most
not.
of it. Yeah.
Yeah, they're maybe not building agents yet. And I'm trying to think about the inflection point of I'm architecting out a new functionality in my app, and at that point, I realize, oh, I need to spin up some Daytona,
Environment.
essentially.
Yeah,
Yeah.
so I think Vedran will be best to just like go into details of what you can do, but just like high level, and I'll pass it to him. Like the most promising one, or the one you need is like if an agent has to clone a GitHub repository to do work, where does it do that?
Yeah.
Like
Okay.
that we like the Daytona's yet like there's nowhere to do it. It has to do it somewhere, right? An interesting one is like we've had recently, whereas a customer they have an agent that they have one. There's one that has an agent that plays video games, and there's one that has an agent that builds video games. And so, how is it going to play a video game? Like, where does it install this game? Like, there is
Mm.
nowhere an agent can do that in its head, right? It needs a machine to be able to do these things. Obviously, there's like data visualization and downloading files and using dark data sets and analyzing these things. These are things that an agent cannot do in its head, nor can a human do in its head, right? It has to be done on an actual machine. So the thing is, we've had this discussion before where people are like, oh, why does my agent need these things? Can it just like, you know, whatever, do it on its own? And then you ask ChatGPT a mathematical problem, and then it gets it wrong because it tries to write it out in its head versus calling a machine, a calculator in this instance, the most simple machine.
Okay.
But it still calls out like a box like ours and runs a Python script that actually calculates the numbers. Because if you do this right now, you can actually try this probably, and say like, give me the percentage difference between two numbers. It will try to solve it like we did in high school, like it, on paper. It will try to solve the
Mm.
problem, and it gets it wrong 15% of the time, probably like a human does, right? And so instead of
Yeah.
calling a computer a calculator in that instance, it'll try to do it in its head. And so that is why you need a machine. You need a machine to do absolutely anything complex in the digital world. You do need a runtime, a sandbox, a machine, essentially.
Yeah. Vedran, are these always? Well, I was looking through the code examples and the
Mhm.
documentation. Is this always? Uh, you call them sandboxes, but are they
Yeah.
always based on containers? Does it have to start with a container image?
So yeah, so actually they're not technically containers. Um, in our open source version, you will see that we use Docker, but we have also proprietary what we call runner that
Mm-hmm.
actually spins up these light virtual machines for
Mm-hmm.
better isolation and performance. Yeah, and also talking about isolation, if you look at it, the code that agents execute is usually untrusted code. It's by design, right? So
Right.
when language model creates a snippet, a human is not in the loop, right? A human does not know what's going on. So if you're gonna approve each snippet, you might be fine, but the moment you start automating and you let your agent do the work, it becomes untrusted. So what you really want is to run that code somewhere that is not where your agent is running, or even worse, on your local machine. And that's also one thing that we solve. The other thing is that these compute operations, they can be very lightweight, like running a code snippet, but they can also be very heavyweight, like processing a large data set, or even creating a full stack app, which our users or their products are actually building. So Daytona Sandbox allows spinning and running hundreds or thousands of these environments in the same moment, and that by itself is a complexity, right? So
Yeah.
also these environments need to be fully configurable, and we built Daytona to support multiple ways that that an agent can configure that environment. It can be pre-built from a Docker file, or it can be created from an existing Docker image. We also support what we call declarative building, so that agent can specify the runtime configuration by using a set of commands. And in that way, the agent can, let's say, build these environments on the fly, so they don't need to be pre-configured. And in that sense, in a way, these sandboxes can be related to a Docker container, but on the other hand, they serve a very different purpose in the agentic context.
Okay.
Does that reason with you, or you have any follow-up questions?
I'm coming at this from, the idea of, I've got, I'm the guy that's running the Kubernetes or the AWS infrastructure that traditionally the developer architect that's deciding they somehow need an isolated environment, like they're going to probably come to me and say, like, can you spin up a bunch of containers fast, or can we do functions as a service, or lambdas or whatever to do this. And I think I saw somewhere that you all, I think maybe it's on Product Hunt, where you mentioned like you were frustrated with startup times and like all these things that are problems in the current world, and you felt like that wasn't good enough for how agents needed to be designed. Can you talk a little bit about that?
Sure. So we originally started with Kubernetes as a orchestrator for these environments. But the thing is, Kubernetes is a great product, but it is built for reliability, right? It's built for running application workloads, and it's not actually meant for sandboxing. So with Daytona, we actually build these sandboxes. These are not the environments where you're going to run your production workloads, right? So we created our own thing that is extremely fast. And on the other hand, as I said, it doesn't emphasize reliability; it emphasizes velocity and performance.
Okay.
So that's the main difference. So both Kubernetes, both Daytona, they can provision these workloads. They can use multiple nodes and scalability. But the difference is that we built our system for velocity, and Kubernetes are built for reliability.
Right. So if I'm building this agent version of my podcast maker imaginary scenario, I'm running that traditionally, right? Like that's just code I wrote, probably with the assistance of AI, but I've put in a container. I'm probably putting it on something Docker or Kubernetes, right? And then that is using your SDK to spin up a rapid amount of sandboxed environments that
Sandboxes.
I guess it's going to have possibly some tools that is probably based on, it's not going to be an empty container with nothing in it, right? Like it's probably, because I think I was looking through your SDK and I saw that you have sort of like the SDK for all typical Linux functions, right? Like copying files in and out, and I think some of the sort of the typical stuff that we would do if we were sitting on the system itself. But writing files, finding files, stuff like that. But in this case, I guess I'm going to have some sort of base image with probably some of the tools that I know this AI is going to need all the time anyway, and then my agent code is just using your SDK to do the ins and outs and spinning these things up. Like you said, you could have options for volume connections so that if there's any persistence inside of those, I can do that. And then it just tears them down at will. And me as the infrastructure person, I didn't have to write any Kubernetes or expand my cluster for that. It's all completely, and I think I saw on your website you have like five or more locations in data centers, so you can spread these things out or call them from a different region. Am I getting all that right?
Yeah. So you said it really well, and you can think of Daytona as an actual on-demand compute for your existing application, right? So your application is deployed on AWS, on any other hyperscaler or well-known application hosting. With Daytona, you get, let's say, unlimited compute for your sandboxing operation. So you can think like of processing processing a large data set, running untrusted code, all of these things that you don't want to run in your agent context. And one more thing, just like to mention, we are fully persistible, not only with the volumes feature, but these sandboxes itself, they are fully persistible, like they persist entire file system. The volume feature is an add-on to that you can pre-populate a large data set and share it between sandboxes. And this is a unique feature of Daytona.
Yeah, nice. And I'm just sitting here thinking, like, it's also potentially long running, right? Like we had a show a couple years ago. Was it a couple years ago? I felt like last year we were sort of comparing Lambda and ECS and EKS and sort of like different workloads and the pros and cons of going to serverless essentially, and long running things that need to spin up outside of an HTTP call. Like there's a lot of scenarios where Lambda just doesn't make any sense. And I think I was reading your documentation, like you can these things can run indefinitely if you need them to.
Forever. Yeah. We have users that run their sandboxes for days or even weeks. So it's not that uncommon.
Yeah, so I wanted to add on this difference between like us and a Lambda. Of course, it's that it can run for a very long time on purpose, but it's also all the tools that we enable for the agent. And so there's a new, what's a new buzzword, which is agent experience. So of course, there's an SDK for the state of the machine, spinning it up and down and archiving and deleting it, whatnot. But the bunch of tools, as you mentioned earlier, so we are essentially helping the human or the agent in this sense, the developer. And so Vedran and the team built out a bunch of tools that outside of the dependencies are in there, which you slightly mentioned, which is a terminal, a file explorer, a LSP, a Git client. All these things are headless inside of each of the machines so that the agent can interact in the most efficient way or get the job done in the most efficient way, right? It doesn't have to parse terminal output. It sends a command as a string and gets a reply, nothing to think about, doesn't waste time, doesn't waste context window, doesn't waste tokens, and gets a higher quality of outcome, right? And so it is much more than just being super fast and serverless in the sense of it's a serverless field, but it is persistent. It has all these tools. Also, the agent can decide on the size of these machines. So how many vCPUs, how much RAM, how much disk it needs. All of these things can be defined through the SDK. And as we build out more things, it's about how do we solve more problems for the agent. And one thing we didn't mention is computer use, which is coming up, where this is basically just API endpoints and commands that an agent can do, but there are some that want computer use, right? It wants to like open up a application, a website, whatever it may be. And so can we build that in a way that works for the agent? Because if anyone's tried computer use, it's not exactly the most effective way for an agent to work. It has to send screenshots of a machine somewhere else, and that it costs tokens a lot to digest that, and they get a screen every 4 seconds versus if you have a like 60 frame per second, and I know people have much more, you have a few hundred of these in a second in 4 seconds versus just the 2 that they have. And so how can we think about Daytona and make it easier for the agent? Like what can we do in the SDK? And there's a bunch of things coming up which we're excited to show the world, and how an agent can do things in the computer use visual mode only when that is necessary. If anything can be sort of done through a deterministic endpoint, we switch it to that. So it gets more done. And there's also a lot of white papers about this. If your agent is in hybrid mode, in a sense, it has to use computer use, but it has APIs to send and receive commands, it has at least a 20% more higher probability of successful outcome, right? And our job now is not just to take servers and make them easy or fast, like a Lambda, but make it specifically for the agent and it's to be able to execute on its task. And that is something that we as humans like have all the tools already on our laptop to do that, but agents actually don't.
Okay. When you look at the architecture of this, because it feels like it follows current similar patterns, but do people follow sort of one sandbox has like one tool per sandbox, or people just bundling a bunch of different tools into one sandbox image and throwing the AI at that? Or because we talk about context windows and don't give it too much stuff, and what is the design? Is there a consistent design pattern here about how they build these sandboxes?
We encourage our users to spin up as many of these sandboxes as they need, and to keep them short living, right? Ephemeral use. But again, there are users that just bundle everything into one sandbox and they then treat it as a sort of a virtual machine, which works in Daytona. So we are very proud of that. But on the other hand, we would always encourage our users to spin as many as they can, because as said, we are built for velocity, and if there are any problems with any sandbox, it is very easy to restart, right? So keep them lightweight, and that's the best way to do it, right? And if you empower your agent to use it, then again it depends on the type of agent, right? Some agents are basically very simple and they are operated by language models, and then it depends on how language model decides to use us.
Yeah, I'm sitting here thinking this is like it feels like it might actually be more cost effective to do the I don't know if we want to call it a microservice, the micro agent. Just because, otherwise, if I put a bunch of stuff in there, like you're talking about computer use, like it's gonna be a big old image. It's gonna need a lot of resources because some things might need nothing, like a git command needs nothing, but opening up Chromium and doing a bunch of work visually is a lot. And if I have to have this machine running and it's always working and it's big, it feels like that could be much more expensive than just little tiny, spin it up, run the git thing, move the file somewhere else, do the Chromium thing, whatever I need. It also feels cooler that I can just spin things up and tear them down.
I think you're absolutely right with that one, Bret, where it's like we charge per second. So it's like we charge on purpose per second because you have like really short living machines. But also, as we mentioned, there's like a declarative image builder in the sense of like your agent can say, oh, I need a new Docker image or a new default template. And I need these 4 things or these 3 things and these 2 things. And so it's much more cost effective to have super small dedicated sandboxes to execute one task or a handful of them, kill that one, and then spin up, or do them all at the same time. But it's way more cost effective than, to your point, having this large one that needs, 10, 20 gigabytes to be able to just get up and running of storage, and then install dependencies, have all these things running and whatnot. So it's much better to do in that way. Obviously, there's more logic to be done in that matter versus just like throwing in the kitchen sink and saying, oh, here's my sandbox, everything's in that, right?
Yeah. I'm always gonna, like, we talked about doing a demo. That would be maybe helpful for those on YouTube. We have a question though. Richard's asking, very interesting evolution of automation. Given human past track record, using the tech for bad will likely follow. Is there something equivalent to Asimov's robot laws for AI agents?
I mean, there is none yet, as far as I know. Like we don't work in the model, the foundation model company,
Yeah.
so
We're
don't
gonna
know.
blame this on the model, right? Like this is the model's
It is the,
problem.
but it is the model. So just in the sense of like, let's talk about the definition of an agent. And
Yeah.
there's a lot, but the way it comes down to is you have the model on one end, and the model is usually an API call to OpenAI, Anthropic, or Llama, or you have it running, whatever. It's the model. The agent is the piece of software. So any like it can be running on your machine, but the agents we're talking about are usually SaaS products, right? So it is a piece of software that's running on AWS and it has a database and it's connected to the model. That is an agent. That's the whole thing.
Yeah.
And it has access to external tools. And external tools can be a Daytona, it can be a browser, it could be Google Drive, it could be like that's
Yeah.
it. So basically, the agent is the intersection between a model, tools, and the human.
Yeah.
That is what it is, right? So there's nothing that you can put in Asimov's law in the agent itself, but the model is where you put it. The model is like essentially the brain and what it can or cannot do. So yeah.
Right. So like the model, like we've been talking about a lot on the Agentic DevOps podcast, the model is the non-deterministic part. The agent is just normal systems code and should be
That's it.
deterministic, right? Yeah. So
Exactly.
it feels like we can all just blame the model.
No, that is what it's
But
exactly what you're doing. And
yes.
we have to blame the model because, to your point, everything else is deterministic in the sense of like the API is integrated with us or Google Drive or whatever, and it's deployed on an AWS, and the front end is deterministic. It's already built out. The the HTML, the CSS, whatever, it's all there. The only thing that's not deterministic and sort of can go rogue is the
Yeah,
model.
off the rails.
Yeah.
Yeah, and if you're, I mean, this is kind of to Richard's question, like what you're creating is part of the solution in terms of the isolation that we have already so many examples over just the last 2 years of people experimenting, but even before we had agents, and all these stories of how MCP's gone bad, how AI's gone rogue. Like I gave the example of on my own system, it was trying to delete system directories because it couldn't build its own code. And to a lot of us, like isolation and ephemeralism are like the solutions, or not the solutions, but a guarding measure against this rogue kind of behavior, right? So like you're saying, if you're throwing this thing away, it's not quite a function, but it almost feels like a function of like, you're going to do a thing and then I want to throw you away and then I'm going to start over because the LLM might have given me the wrong git command and then I'm I'm doing some crazy stuff or whatever. And so when something in my agent code figures out that this isn't going to work and it needs to try again, it's going to toss that whole thing out so that I don't have to worry about, I'm like resetting essentially at that point, right? And this doesn't really solve the MCP security problems that I was supposed to record a podcast episode last night about that because this MCP stuff is wild, like how you're able to hop between GitHub repos.
Yeah.
And you're able to convince an LLM to do things it's not supposed to be doing. You're breaking, what do they call it? Jailbreaking or whatever outside of it. Anyway.
There's a lot of things on, I can talk a lot about auth in general, but I think there's a lot to be done for agents and authentication in general, like letting it go access to services and then MCP or not. Like basically the way I think about MCP, it is just like a machine interface that has to have APIs at some point somewhere, but also the way you authenticate a machine and then what access or what privileges it has inside the service it has access to, that is where a lot of things have to be done. So if essentially an agent like auths into my GitHub and it only has access to one repository enforced by GitHub, then there's no way it can hack into something else, right? Similarly, like a human cannot. And there's a lot of things to be done there. And so the way they're doing it right now is not still the most ideal. But back to your point where we're talking about isolation, there's also each machine is isolated, but you can also or will also be able to define inbound and outbound requests as well to this. That's something upcoming so that you can say, oh, here are my sandboxes, but it can only access XYZ websites and only incoming traffic from this thing. So then you're kind of sure where it's going to go because there's actually a firewall stopping it from, going rogue outside of it as well.
Okay. Yeah, one of the predicted, this is maybe a topic for another podcast, but as I'm trying to figure out how to use AI and agents and MCP inside of systems work, like DevOps and platform engineering and infrastructure, you know, we have this problem, this old problem in CI world where we would give Jenkins or whatever we were using for automation. Essentially, it becomes the biggest security threat of your entire infrastructure because it has the keys to everything. It can write to production. It can write to the Git repos for storing the infrastructure YAML. It can access the cloud APIs. It has like all the keys to everything, and so it's a target. And now I'm seeing very quickly where we're just throwing everything to the LLM, and we're giving it a bunch of secrets and tokens, and now it can go.
We should not do that. We should not do that. We should not do that. Yeah.
Yeah, and I mean, that thing is coming, right? Like we were talking about on the first episode of Agentic DevOps, where at KubeCon, I got to sit in an analyst event, and this is the European one that was in London a couple of months ago, and I was hearing language coming out of Europeans that were there, and media analysts, stuff like that. That was like, I literally heard the words, my client businesses that are global brands want to remove all humans from operations. Humanless ops was the term they used. And we're at an infrastructure conference. So it's like there's 12,000 people here that are all that you're saying we don't need to exist anymore.
Yeah.
And it was weird. It was a weird moment of sort of like the looming expectation of business around AI hype coming to us engineers, expecting us to do magic when it doesn't really exist, at least not yet. And then like this absurd expectation that at an infrastructure conference that we're somehow, that even we don't even though we can use AI today to speed up our work and to do things faster, that the idea that we don't even need the humans to manage that anymore. It was just such a moment of like, is that guy for real? Does he believe this? So I feel like we're in a world where us operations and DevOps people are going to be asked to do these things, these crazy things, like give the AWS token to the LLM so it can go build infrastructure for me. Like these are things that either they're not happening today, we're going to be asked to do it, or at least try to make it work. Because if all the that's my theory, if all the devs are writing all this new code and they're shipping faster and they're AI assisted, we're already seeing like 20% performance benefits on the average dev. There's a couple studies out. So it's not 10x, but it's something. And so if they're all speeding up, and the business is somehow expecting, like the general business vibe is like, we're going to reduce costs with less humans. I don't believe that's going to happen. I honestly think we're all going to go faster. And if every business has AI, they're all going to have to go equally as fast. So if they get rid of their engineers, like they don't have competitive advantage. Anyway, that's my theory. That the rest of us that are on ops side, we're also going to have to do something. Because now they're throwing more stuff at us. Now they're writing more code. They're having more iterations than they used to. And we all think we're just going to sit around, and I guess you have to, if you're a really amazing top tier DevOps engineer, maybe you've automated yourself out of everything and you don't need to be around anymore, and they can just ship faster and you have to do nothing. But most teams I know aren't there yet. They're not the Googles or Netflixes of the world.
Oh yeah, it's not there yet. And I think that the person you're mentioning, I don't know who the person is or the conversation, but like you have two sides of it where you have like the people that are like, oh, this is today, and then you have the demo of it doing whatever, and it's not today. But the thing is, like every 6 months, like it becomes that today, or something becomes today. So these things are moving like really, really fast. And I think a lot of these things will change, and I don't think humans will be erased, but in the sense of like, will a lot of these things be run by AI, especially on the ops side? I'm pretty sure they will, but they'll be rewritten. Basically, I obviously from the viewpoint we have, we're basically doing your local operations. What we're doing is helping what an engineer would do on their local machine with Docker, with Kubernetes, with like, as we mentioned, there's like a bunch of these tools that you have in your machine. We've now automated all that out for the agent, right? We have a version of what you do on your machine for the agent. Now, at some point in time, what that point is, I have no idea. Is it like in 3 weeks or in 35 years or in 300 years? I don't know.
Right.
Like AWS will look completely different. Ops will look completely different on the production side. And then all of that, what we're doing for what we're doing is like your development environment on your laptop for an agent, there will be something similar for an agent on the deployment side, right? And on CI and the deployment and testing and all these things. And so where does that when I don't even think that they're at the cursor copilot moment yet, let alone the
Yeah.
full agentic autonomous moment yet. But it is to be expected that, as you're saying, like a lot of these things are being done right now, that this will be done as well. And I can like I just have 2 points that I can add
Mhm.
to you. It is when you look at the vibe coding apps, which again, these are the most simple applications that can be done. It is like can make me a flower website, right? That's running on one machine. We're not talking about, launching booking.com. Like we're not talking about that. And so the agent actually deploys it automatically by itself. So it uses like Supabase as a database for Neon all by itself. It deploys it to Netlify or Vercel all by itself, right? There's these things, but these are very simple tools. And you can sort of extrapolate that at one point in time, it will be able to do these sophisticated things. I think we're ways out, but that is the future that we are heading to for sure.
Yeah.
I don't want to get you too depressed. I'm sorry about that.
No, it's just it's so much.
It
It's a
is a
lot.
lot. It is a lot.
It's a
It's a lot.
lot. And I mean, one of the things we're trying to do on this show is like to break down break down the hype, break down let's come back down to what actually is working, what people are really doing today. But the velocity of all this and the newness of it is, I don't really
It is
feel like I have
remarkable.
an analogy equivalent in my career of 30 years of,
Yeah, it's really
Yeah.
new, and I just want to set in the numbers and why I think this is important. So Neon, the database company, which was just acquired by Databricks, 85% of databases spun up now are by autonomous coding agents. 85%, right? So that's 4x the time, the amount of, or even more, are spun up by agents than by humans. Albeit these are simple use cases, but just the
yeah.
the actual like size, the volume of these things being created is quite a bit. And I'm probably don't have the latest number, but Netlify at some point a few months ago, it was 10,000 websites deployed by agents a day. Like, and it's probably a lot larger than it is right
Oh,
now.
wow.
So like it's a lot. And again, these are
Yeah.
simple websites and it's not a straight line from like make me a personal website or a flower shop website, deploy to Netlify, and again, build out I'm making up booking.com or whatever. Take your like large website you want in the world and deploy that, which is super complex. It's not a straight line. There's a lot of things to do there. But I'm
All
just
right.
saying like there is actual numbers and velocity of these things. And the reason I think that people are like, oh, we got to get rid of ops people is because they see that they can do it by themselves and lovable and launch a website. Like,
Right.
why can't you launch that same website? Because it looks the same, right? It's the same thing. So
Right.
yeah.
Right. Yeah. In terms of, yeah, there's a level of complexity there where I mean, in general, I do feel like every quarter now, like the line has been moved. Like
Yeah.
the the simple the vibe coding, whether you're in an IDE or something like Lovable or whatever, like that line keeps moving and moving to more complicated scenarios. Now I can
Mm.
finally have my chat GPT create the images with words that are English words. Like that 6 months ago, we're like, you can't really do that. Any of that, anything that has to have words on it, you're going to need a photo editor. You're going to have to put some, you're going to use Canva or something. And now all of a sudden, I just don't need any of that in certain scenarios.
Yeah.
And that line keeps moving too. So it's
I can give you another one,
Yeah.
which is more ops focused. We were trying to build out in an old version of Daytona, like an agent that would build out a dev container file looking at a GitHub repository. So you have a repository and you want to be able to check it out and just build it at development time and just have it running, right? And like that seemed like a logical thing. There was no way 6 months ago, there was no way we got that running. It was just like it kept putting in like whatever it saw most often in a dev container JSON. That's
okay.
what it put in there. That's it, right? That's all it did. And like try to figure out, didn't really work unless it was super simple. Now there are two products, as far as I know, and I haven't tested them out, that claim that they do this. And so it will be either a Docker file with a dev container or just a Docker file or just dev container, whatever, depending on what the use case is, and it'll do it all by itself. And so like that is that's a lot of work there. Like that's not a trivial thing. And again, I haven't tried them, so I can't verify, but they claim that it works. Again, claim
Yeah.
versus
Yeah,
real,
so
we'll see.
with every new generation of models, new things become possible. So I think it was Sonnet 3.5 that basically
Yeah.
brought up the whole revolution with
Game
cursor
changer.
and
Yeah.
yes, yes. So before Sonnet 3.5, there was I would say more basic use that you could utilize these models like for auto completion or for detecting some errors in the code base. But from Sonnet 3.5, we saw a massive adoption of these autonomous agents that could basically do almost like entire projects on their own. And now we see new generations of model opening new possibilities. So I think that, yeah, you are right. Every 3 to 6 months, there is a leap in what can be done. And that improvement that models bring need to be followed by agents. And I think moving forward, we'll see more and more autonomous use in both like simple use cases and more complex ones.
Yeah. I want to shift gears real quick for a couple minutes. You have this GitHub repo, the AI enablement stack
Yep.
is, and I remember when I first saw this, I know it was months ago that you put this out or last year or something.
Yep.
And it looks like your own version of the CNCF landscape, which is
Yes. So
hundreds of
kind of.
product logos, or looks like 100 product logos, and most of these things, well, maybe half of these things I've heard of. What's the goal here?
Oh, the goal there was basically, and this was, we built this when we were before our pivot to agents, and it was sort of like
Yeah.
thinking about what does that stack look like for building agents, right? So if you look at the graphics, it starts very much at like the hardware layer. So you
Oh, I
have
see.
like
Yeah.
you have the cloud providers, right? And then adjacent to them, we put them on top of the other. It is the LLM providers, but they're both like underlining infrastructure. Then we sort of looked at where we would fit, and it's like it's on top of hardware essentially because we sort of augment the hardware for agents. And then it's like, okay, what are the things on top of that? And so what are the all the layers up to the actual agent itself? That the human interacts with, right? So there you have like frameworks and knowledge engines, which those are basically databases specifically for agents. Frameworks are these frameworks that help you build out the agents as a human. And then on top of that, we have the rest of the layers. And as you get up, you get all the way to the actual agents that consume it. So the agents that consume it are like OpenHands and Devin and even Cursor to an extent, because it actually uses all the layers underneath to be able to serve the human what they want.
Yeah. Some of these layers, like the engineering layer, I don't think I recognize a single, other than Code Anywhere. I don't think I
Oh
recognize.
yeah,
Oh,
so
source graph. Okay, source graph. Yeah.
there's a bit there. I mean, LangGraph is there, LangFuse is there,
Yeah.
SourceGraph you've heard of obviously, and so there's a bunch of them, and also it's like an open, unlike. I mean, it's not like the CNCF in that sense. This is a GitHub repository. Anyone can contribute. So if anyone finds a new tool or thinks something that makes sense, they can like open up a PR. And if it makes sense, we do add that. So the idea is to have a living sort of visualization of these layers of what is needed to actually build an agent from the hardware layer all the way to the agent that's consuming it before the human interacts with the agent, right?
Yeah, like the OCI layers of AI agents. Yeah, it's pretty cool.
Kind of, yeah. That's kind of how we think about that, yeah.
Um, all right. Well, we haven't done a demo. Do we want to do a demo real quick?
Let's do it.
All right.
Yeah.
I threw up on my screen because on the homepage you actually have some pretty good examples of just simple. Is this Python? I think I'm looking at Python.
Python, yeah.
Yeah, simple examples of like how to inside your agent code, how to run a process sandbox, or how to run a file system operation, or a git command and stuff like that. And so those are, I mean, that's kind of where when I started to get my basic understanding of what this was all about. We went back and forth in email for a couple of days. Like I'm so I've never created an agent, so I don't understand the problem space. And I'm trying to read the code examples to understand it. And I was
Brett,
like, oh
the
yeah, this is
agent
like,
is you. The agent
yeah.
is you,
Yeah.
and we're giving the tools to the agent. That's how it works. Yeah.
All right, let me jump into screen share real quick.
Sure. So yeah, so we'll just use our Jupyter notebook from our repo that is available. That is fully open source, and it's
Okay.
available
Can you
on
zoom in a
GitHub.
couple times?
So yes, like this.
That'll work. Yeah. Yep.
Okay. Okay. So this is just a basic like bootstrapping. We just need to initiate the Daytona object that we're going to use. Nothing special here. So if I just run it, you just put this into your agent's code base. And then we can create a new sandbox, which is just one liner. Okay. And when the sandbox is created, we can then execute a bunch of stuff in that sandbox. So we'll start with a simple code execution snippet. So this is how easy it is. Like you don't need to worry about anything. You don't need to parse any output. Daytona that has helpers for all of these functions. And if I run the code, you can see here we just executed hello world. So that's the actual output that we got from the sandbox. We can also execute Linux commands anywhere in the sandbox. So again, very simple hello world execution, very fast, like almost instantaneous. And you have to just take it into account that I'm currently in Europe and this is all executed in the States. So there is a network latency from my location. Otherwise, it is extremely fast. So we have more complex examples. Now, I will not run each of them, but for example, this one uses our session executor, which allows you to programmatically create these executable sessions, which are kind of tmux or terminal sessions that you would create on your local machine. And then you can consecutively run multiple commands that will be in the same context. To better illustrate, if we define an environment variable in the first command, then that environment variable will be available in the second command in the same session. So moving forward, we also have some helpers for generating charts. Now, these are very handy if you are using Daytona sandboxes for some research tasks. Like scraping data from various data sources and then creating these charts for creating reports. I think I can show this one. So this one is a bit more complex because it has to download the chart. But again, as you can see here, we have this is all generated from the SDK, right? So there's no extra work on the agent side. We can also create composite charts and so on. We built a really nice toolkit for managing file system, which allows you to list files, create folders, upload files, download files, and so on. Also, we can do regex search and replace, change file permissions, and so on. So again, it is very, very simple. No need to SSH or parse any terminal or bash scripts or commands. So this is very, very straightforward. We also have a built-in Git toolbox that allows agents to clone repositories and check out the different branches and so on, all with a single command. This even works for private repositories. On our documentation site, there is there's a documentation on how to authenticate to private repos. There's even a very simple implementation of language server protocol, so we can connect to existing LSP servers running in sandboxes. And in that way, if coding agents, for example, need to analyze a code file. They don't need to send it always to the model and like on the expense of tokens. They can actually analyze the code base in the sandbox and then just extract what's relevant. And also, yeah, you can, as said, these are not just ephemeral. These can be long living, so you can stop, restart, archive, restore, and so on. We will soon we will enable also fork and pause and resume. So on top of that, upcoming is also the computer use API. Unfortunately, it is not available yet. So maybe it's a good opportunity for some next podcast. Yeah, that's it basically. So we have also a bunch of other examples that are more like they're written in a separate folders, and we have SDKs for TypeScript and for Python.
Yeah.
Any questions?
Yeah, Robot's got a question around. You know, I think we talked a little bit about this earlier about if these are using MCP in the background, and I think the answer is that it's not, because you're writing. This is an SDK, which allows me to avoid MCP, right? So like because the MCP to me would be the LLM calling out to the tools it needs.
Sorry.
But that's a different paradigm, right?
That's exactly. So as mentioned in the I replied in the chat that was already there. These are all part of our API, and as Robot saw, like his question was, these are all bespoke tools. Cool. Yeah, these are all things that are built inside of each of the sandboxes and exposes these API endpoints through the same SDK as the sandbox itself. And so there is an MCP if someone wants to wrap the whole thing together. So managing the sandbox and the tools, there is an MCP for that. But these tools are not MCP. They're actually tools that come prepackaged in each of the sandboxes.
Yeah, I feel like do you have a architecture diagram of the conceptual layers of like
TBD.
Yeah,
we haven't done that. TBD.
Gonna kill me.
I'm gonna kill it. Yeah, we have to do that. So yeah,
not yet, but we are gonna put one on the documentation side.
You got like this agent concept, and those of us who haven't written one, we're having, I think, I'm the same with Robot. Like all week long, I've been going, okay. So I got my LLM. LLM calls MCP tools. I got my agent code that I'm writing. It's using your SDK to spin up sandboxes. My agent's probably just a container that I built. It's in a repo that's running on a Kubernetes somewhere long. It's running a long-term process, and it's calling out to a foundational model. So I'm not running my own models probably, unless I'm a super fancy ML engineer team. So I was trying to do all this work in my head, right? Mental exercise of how these parts are connecting to each other. What's the protocol? Like one's a SDK call in my app code. One is a MCP call, which is essentially gRPC or HTTP. Yeah, there's a lot going on here. And then if you're not, I mean, a lot of these things we weren't even talking about 3-4 months ago. So I totally feel the pain, which is why I hate to keep plugging my podcast, but this is why we created the podcast, so we can try to.
In all honesty, a year ago, I was reading white papers and Vedran, and we're calling each other on the phone, and we're like, oh, so we're doing what you're doing right now. It's like, so this is this thing, this is the model, this is an agent, this is like, so yeah, it is a whole new paradigm that we all have to get used to.
Yeah. So diagram TBD, Robot.
TBD.
In fact, I was going to sit here and actually write it in a Scala draw. Let's see if I can come up with something, but I don't think anyone wants to watch me fumble around in a design tool for 5 minutes. So, all right. What else did we miss? Is there anything else we?
I don't think we missed a lot. We went through a lot of things about basically talking about what is an agent, what is a tool, what is Daytona. Hopefully, if I have to leave something with someone, it is essentially, as you've seen with these tools, it's like we are Apple in that sense, giving you the Mac with the pre-installed apps, sort of, that made for an agent specifically, and you kill the machine, or you throw it in the garbage after every single task. That's sort of the equivalent of what we're building out here.
There's one thing that I forgot to mention while is my camera frozen?
It is, but just keep going, man. Just keep going.
Sorry about this. Okay. Anyways,
fine.
one thing that I forgot to mention is that we built tools for human in the loop. So we are not just thinking of agents, we are also thinking on that there is a need for a human, and there is an often need for a human when there is agentic work going on. So we built a fully featured terminal that authorized users can use to access these sandboxes to debug or see what's going on. We are also working on a whole lot of features for auditing and for logging of what the agent or what happened in particular sandbox, so that there's like a trace or a set of logs and metrics that humans can then use to evaluate these actions, or they can then use them for evaluation tests or frameworks later.
All right.
We still need humans. That's what he's saying.
Yes. What is the difference between you have an open source version
Yep.
on GitHub, and then the product? What you mentioned earlier, like that the open source did something different. So I was curious.
So the open
What you're
source,
thinking.
we run containers, which are Docker containers. In the proprietary one, we run micro VMs. That's the whole difference, basically. There's some features that will be different down the line because of that. But as far as like base functionality, anyone can use the open source and get 90% of it of the usage that they need from that.
Yeah, the whole application logic, everything is in the open source and is the same repo that we are using for our production.
Yeah, and the Daytona SaaS is you're running all this on your infrastructure, right? So it's just a bunch of API calls from my app. Is there an on-prem version yet, or are you going to stick with SaaS? What's the plan there?
So there is a BYOC coming where you can bring your own compute to that. On-prem maybe later down the line, but BYOC is something that we're already working on with a few partner customers right now. So it'll be our control plane. We won't see basically anything that's happening there. And you can bring your own machines where the sandboxes will be run.
All right. And you also run a dev conference or something, right? Like I keep seeing you posting about these one-day things, or
I know. Oh, we do a bunch of events. So I used to run a conference called Shift. It still exists. It's in Croatia. It's about 4,000 people. So anyone in the dev space is there. So we had speakers and sponsors from, Postman, Docker, Microsoft, whatever. Everyone's been there. I used to run that. I sold that. Or got acquired is the better term. And so with Daytona, we no longer do conferences, we do tools, but we do a bunch of events around the world just because I guess I have that, gene or bug or whatever you want to call it. So we have one-day events all over the world, like across North America, Africa, Asia, South Latin America, absolutely everywhere. So people can check it out on our Luma or on our socials, like we post about them all the time. So yeah.
Yeah. I think that's what I've been seeing is like these one-day events. There was like 100 people in the room or something.
250. We get like 250 people in our meetups, like a lot.
Yeah. And is it like all AI topics? Like
it's all AI.
It wasn't
topics,
just Daytona stuff, right?
No. The idea is so we call it AI builders, and so the idea is like we offer knowledge or tools about how to build agents. So we have we had a speaker from LiveKit, which is like low latency audio. So you can think about it like if you have talked to ChatGPT, that is one of their customers, and they do the stream of the audio for that. We had one with the founder of Browser Use, which is a similar in idea with Daytona, but it's basically the browser. So if your agent needs a browser, like they have a great browser, and your agent can use that to do things. And so it's basically people like usually like founders that are creating tools or new way or frameworks for building out agents. So anyone building agents, it should be interesting to them, right? To come listen to these people.
Right. Is any of that stuff recorded on YouTube at all, or do you got to be there?
Oh yeah. Depends on where. So the ones that we do at GitHub, so we do quite a few in the GitHub offices. They're all on our YouTube, so you can take a look at that. All the talks there. Yeah.
Yeah. Awesome. More learning for me. I've only got a list of like 50 YouTube videos that I have to watch this week.
Yeah.
Everything from Fireship to Google Cloud explaining agentic stuff to MS Build. There's just a never-ending avalanche of content around AI right now. So, and that's not even talking about the models. Like I don't care about models necessarily. Like I pick the tool and I choose one and I move on. If it doesn't work, I change to another one. Like that's not interesting to me. It's never been interesting to me to compare tools and talk about the SWE bench and all that stuff. I'm like, who cares? I just want to get the job done. I'm not interested in model design and all that stuff because I wasn't an ML engineer and I hopefully don't have to become one to use all this stuff. So
I don't think you'll have to become one. Yeah, I'm pretty sure.
Yeah. Well, it's been a great show. I thank you so much for showing up on the show again. This is now the first time you're together. Hopefully we'll do this again and we'll be talking and complaining about AI, I'm sure, for many years to come. So
absolutely.
Yeah, thanks for being here. So Vedran, Ivan, sorry. You can find them at Daytona.io. I in the show notes I will be putting all their social links, and I'll put the YouTube in there since someone's probably interested in some of your AI agent videos. I'm sure if I watched some of those, I probably would have understood the premise before the show. But
no worries. There's so much. To your point, there's so much content. I think I spent the last sort of year every like free moment just like either reading white papers or watching podcasts, and it's just like you cannot not do that to understand what's going on. And at some point, I have to tell you, at some point, it's like, oh, I've watched them all, or like I've watched all the ones that are interesting. Like, and now I get it. It's not that much anymore. So you've come up to like the level of what is being released. So
yeah, like when the concept of agents came out, I felt like I had a flood. And then when MCP, well, MCP was announced, but then all these companies started actually providing MCP endpoints, and then that's when I feel like I had another huge. You're right. There was a moment like 2 months ago, maybe even just a month ago, where I felt like I was doing too much learning and not enough doing.
And that's exactly what
and I was like, I'm learning a lot, but I know that like the rules of this is that 80% of that's all leaving my head anyway, and so I need to get my hands on and start doing stuff. And that's when right around the time when Docker launched the MCP toolkit, Docker model runner, all their new AI features, and that was like my entry, my gateway drug, I guess, because I knew Docker Desktop, I knew the infrastructure of how all that worked, I understood containers and images and Docker Hub, and so the next step into running local models, I mean, I'd done with the Olama, but that sort of hides it all away, so you don't really think about containers and networking so much necessarily in Olama. And so that to me, with Docker launched those features, that was sort of my adventure into playing more with MCP. Still haven't created an agent, but I think I can probably turn my hobby project into an agent.
You can hack one together. I'm pretty sure.
Yeah. So all right, I'll be signing up for an account when that happens. So because I don't want to have to manage this infrastructure or solve. If it's a solved problem, I don't want to have to try to solve it again myself. Right. So. Well, thank you so much for being here. And next week, actually, let me check it out. I should have had this up so that I was ready. But next week, we are on a tear of AI, and next week we have no plans. So next week is a Q&A show. But in 2 weeks, we're going to have Heroku on, and we may not say the word AI for at least 5 minutes. We're going to talk about cloud native build packs. And we've already had Heroku on talking about their inference runner stuff now, but we're going to talk about not even a new thing, like something that's been around for years, cloud native build packs. They're going to try to convince me that I should try that instead of Docker files. So we're going to have like a little debate on, because I'm the Docker file guy. So and I actually got to have lunch with one of the creators and at KubeCon, and we were sitting there for like 45 minutes, just going back and forth. I was like, we should be doing this on a podcast. So we're gonna talk about cloud native build packs and the new CNCF project around that and all that stuff. So stay tuned, everyone, and we'll be back next week on YouTube Live. Ciao.